Welcome to KR Tutorials. In this video, now I am going to explain few example sums in trigonometry chapter. So here one example number 1. Question is, if tan A equals to 3 by 4, then find the other trigonometric ratios of angle A. So in a triangle, tan A value given 3 by 4, then we have to find the other trigonometric ratios. Remaining all trigonometric ratios we have to find. So here which one we have to take as angle A? So for this, say for example, we are considering one right angle triangle. Say for example, this right angle triangle is ABC and right angle is at B. So this one we are taking as angle. Why? Because here is given A is angle A. So now we have to find 6 trigonometric ratios. In the tan A is given. So remaining 5 trigonometric ratios we have to find. So in the solution, okay, in triangle ABC, so angle B equals to 90 degrees we are taking. Right angle at 90 degrees. Next, what is given? See here given tan A equals to 3 by 4. Tan A equals to 3 by 4. So tan A equals to 3 by 4 means what? We know tan A equals to the ratio between opposite side to adjacent side. So the ratio between opposite side to adjacent side is known as tan A. So here 3 by 4 is given. So what is that mean? Here opposite side and adjacent side both are in 3:4 ratio. So when you take this one as angle, this is for opposite side and this one is adjacent side and this one is hypotenuse. This is hypotenuse. So here tan A value 3 by 4 given means what? Opposite side and adjacent side both are in the 3:4 ratio. So 3:4. So say for example, let opposite side means what? BC value 3K, some value K, 3K. Then what is B? AB adjacent side AB value 4K. So when this value is become 3K, then this is 4K, 4 times of K. So again 3K 4K ratio is 3:4. 3K by 4K means KK gets cancelled, 3:4. So here if you take opposite side is 3 times of K, then adjacent side becomes 4 times of K. So now we have to use Pythagoras theorem to find the hypotenuse. So by Pythagoras theorem, the square of the hypotenuse. So AC square equals to AB square plus BC square. So AC square equals to AB square value is what? 4K whole square plus BC square value 3K whole square. So AC square equals to 4K square means what? 16K square plus 3K square value 3 square 9K square. So AC square equals to 16K square plus 9K square. Then AC square equals to 16K square plus 9K square, 25K square. So AC square equals to 25K square. So then AC equals to the root of 25K square. Therefore AC equals to 25 square root is what? 5. K square root is what? K. So therefore hypotenuse value is 5K, 5 times of K. Hypotenuse value 5 times of K. So now we know 3 sides of a right angle triangle. Opposite side 3 times of K, adjacent side 4 times of K, and hypotenuse is 5 times of K. So now we can find remaining all trigonometric ratios. So in that first one is sine A. So here angle we should consider as A, already given in the question. So sine A equals to what? The ratio between opposite side to hypotenuse. So opposite side to hypotenuse. The ratio between opposite side to hypotenuse is known as sine theta or sine A. So here opposite side value are 3 times of K by hypotenuse value are 5 times of K. So K gets cancelled. The answer is 3 by 5. Sine A value 3 by 5. So next second one, that is cos A. Cos A. So cos A means what? The ratio between adjacent side to hypotenuse. So adjacent side by hypotenuse is known as cos A. So your adjacent side value is what? 4 times of K. By hypotenuse what? 5 times of K. Again K cancel. 4 by 5. Cos A value 4 by 5. So same like that. Next third one. So here tan value already given. So no need to find. So sin cos tan after cosec value we have to find. So cosec A equals to what? So the ratio between hypotenuse to opposite side is known as cosec A. So your hypotenuse is what? 5 times of K. By opposite side is what? 3 times of K. Again K gets cancelled. So the answer is 5 by 3. So next fourth one, that is sec A. So sec A means what? The ratio between hypotenuse to adjacent side is known as sec A. So here hypotenuse is what? 5 times of K. By adjacent side is what? 4 times of K. 4 times of K. Again K gets cancelled. So the answer is 5 by. Okay. So the answer is 5 by 4. The answer is 5 by 4. So next fifth one, that is cot A. Cot A. So what is cot A? So the ratio between adjacent side to opposite side. Adjacent side to opposite side is known as cot A. So adjacent side is what? 4 times of K. 4K. By opposite side 3 times of K. Again K cancelled. 4 by 3. So these are the remaining trigonometric ratios value. When tan A equals to 3 by 4, then sin A equals to 3 by 5, cos A equals to 4 by 5, cosec A value 5 by 3, sec A value 5 by 4, cot A value 4 by 3. Next second one, example number 2. So here example 2 given, if angle A and angle P are acute angles such that sin A equals to sin P, then prove that angle A equals to angle P. This is the question. So here angle A and angle P are acute angles. Acute angle means what? Less than 90 degrees. Angle A is less than 90, angle P also less than 90 degrees. And sin A equals to sin P. So sin A, sin P means these two are different triangles. Sin A equals to sin P. Then we have to prove that two angles, acute angles A and P are equal. See, in the solution, so we are considering here two right angle triangles. So here this is first right angle triangle. Say for example this name is ABC. So right angle at B. See here angle A is acute angle. This is less than 90 degrees. Next here one more triangle we are considering. So this is say for example PQR. So here right angle at Q. So here angle P is acute angle. Now we have to show these two angles are equal if sin A equals to sin P. So here what is given? See angle A and angle P are acute angles given. Okay, acute angles. Yeah. Next, see in triangle ABC, angle B equals to 90 degrees, and in triangle PQR, angle Q equals to 90 degrees. So first write sin A value. Here sin A equals to sin P value given. So sin A equals to, sin A means what in this triangle? When this is the angle, this is what opposite side, and this one is adjacent side, and this one is hypotenuse. So in this triangle, when this is the angle, this is opposite side, this is adjacent side, and this one is hypotenuse. So sin A means the ratio between opposite side to hypotenuse is called sin A. So here opposite side ratio is what? Opposite side is what? BC. By hypotenuse is what? AC. So BC by AC. Next, same like that, sin P value we have to write. Sin P. Sin P equals to what? When this is the angle, the ratio between opposite side to hypotenuse. So opposite side is QR, by hypotenuse is PR. So from the diagram, sin A value BC by AC, sin P value QR by PR, QR by PR. So now here what is given? See, sin A equals to sin P given. Sin A equals to sin P given. So sin A equals to sin P means what? These two ratios are equal. So here BC by AC ratio in this triangle, BC by AC ratio in this triangle, QR by PR ratios are equal. QR by PR ratios are equal. So in this BC by AC ratio, QR by PR ratios are equal. So these two ratios are equal. See from this, okay. See from this, just QR I am sending this side. So BC QR. Okay, just here similar triangles concept we are using. So BC QR. So these two are similar sides. So these two are similar sides. So just you QR send. See this one. If you rearrange the terms, BC by QR equals to AC by PR. AC by PR. So we can write this one also, BC by QR equals to AC by PR. Okay. Now say for example, okay, these two ratios are equals to, say for example, some K. So here say for example, let this BC by QR ratio and AC by PR ratio both are equals to, say for example, some K. Make it as a equation 1. Yeah, now using by Pythagoras theorem, okay, using by Pythagoras theorem, okay, by using Pythagoras theorem, see here we know BC by QR equals to AC by PR, but we don't know these two adjacent sides. So these two adjacent side ratio I am finding. So in this AB I am taking, in this PQ I am taking. So AB by PQ equals to, see this AB how can we write? AC square equals to AB square plus BC square. From that AB square equals to, we can write as under root of AC square minus BC square. So this AB value we can write as under root of AC square minus BC square. AC square minus BC square. Same in this, PR square equals to PQ square plus QR square. Therefore PQ value we can write as under root of hypotenuse square, PR square minus QR square. So by using Pythagoras theorem. So from this, see, under root of AC square minus BC square value from equation number 1c. BC by okay, here BC by AC. BC by AC value is what? K. So BC by AC value also K. When you just we rearranged the terms. So here BC by AC or QR by PR value K, or BC by QR equals to AC by PR equals to also K. So here BC by AC value K, this ratio. So BC equals to some K into AC we can write. Okay, BC equals to some K into AC we can write. So here BC plus we are substituting that value. So K square AC square. When BC equals to K into AC, then BC square equals to K square into AC square. By same under root of PR square minus QR. See, QR by PR equals to K. Okay, before rearranging the terms, QR by PR equals to K. Then QR equals to K into PR. K times into PR. So when QR equals to K into PR, then QR square value we can write as K square into PR square. K square into PR square. See, in this, what is common? AC square is common. So if you take AC square common, then 1 minus K square will be left. Next, in this what is common? Under root of PR square is common. If you take PR square common, so 1 minus K square. So here 1 minus K square, 1 minus K square left. So under root of AC square value is what? AC. AC square root value AC. PR square root value what? PR. See, this is equation number 1, this is equation number 2. Make it as a equation number 2. Yeah, now see, from equation number 192. Okay, from equation number 192. From equation number 192. From two equations, we can conclude, see, so here equation number 1 is what? BC by QR equals to AC by PR. AC by PR. So here AB by BQ ratio is equals to AC by PR. In this AC by PR is there, in this also AC by PR is there. So that's why these two ratios are equal. So therefore BC by QR equals to AC by PR. AC by PR equals to here AC by PR came. So AB by PQ. AB by PQ. AB by PQ. So from these two equations, so BC by QR ratio is equals to AC by PR ratio is equals to AB by QR ratio. If in a two right angle triangles, if the ratio of corresponding sides are equal, then the two triangles are similar triangles. Already we know in the similar triangle chapter. So that's why these two triangles are similar triangles. So that's why here we can conclude, therefore triangle ABC similar triangle, similar symbol. PQR, triangle PQR. ABC and PQ are similar triangles. So when two triangles are similar, their corresponding parts are equal. So here angle A corresponding part is what? Angle P. Therefore angle A equals to angle P, since CP CD corresponding parts in a congruent triangles are equal. So from CP CD angle A equals to angle P. So hence proved. So we have to prove angle A equals to angle P. So here similar triangle concept we are using. So here by using Pythagoras theorem we have to prove these two triangles corresponding sides are in the same ratio. Hence those two are similar triangles. When the two are similar triangles, therefore their corresponding parts are equal. Therefore angle A corresponding part is angle P. So that's why angle A equals to angle P. Next example number 3. So here one example number 3. Question is, consider a triangle PQR, right angle at R, in which PQ equals to 29 units, QR equals to 21 units, and angle PQR equals to theta. Then find the value of cos square theta plus sin square theta. Second one, cos square theta minus sin square theta. This is your question. So here consider a triangle PQR. Triangle name is PQR and right angle at R. And here length is given. PQ length is 29 units, QR length is 21 units. And angle PQR value theta. Then we have to find these two values, cos square theta plus sin square theta. Second one, cos square theta minus sin square theta. So that's why in the solution, so we are considering one right angle triangle here. So this is a one right angle triangle. This right angle triangle name is what? PQR. But where we should take as right angle at R? So R we should take here. So this is a right angle triangle. So remaining are P and Q. So PQR. So PQR also we can take. So PQR is a right angle triangle and right angle at R. Next, PQ length is given. PQ length means what? Hypotenuse is given 29 units. Next, QR length is given, that is 21 units. 21 units. Next, angle PQR. Angle PQR means what? This one. This one is angle theta. Then we have to find cos square theta plus sin square theta and cos square theta minus sin square theta. But again in this right angle triangle we know only two sides of a right angle triangle. By using Pythagoras theorem we have to find third one, PR length. Then after we can find any trigonometric ratio values. So first here given values, right? So in triangle PQR, angle R equals to 90 degrees, means right angle triangle. Next, what is given? PQ equals to 29 units given, and QR length is given. PQ and QR length is given 21 units. Next, given angle PQR value is equals to theta. So these are the given values. So now by using Pythagoras theorem, so the square of the hypotenuse, so PQ square equals to the square of the remaining two sides, so PR square plus QR square, PQ square, the square of the hypotenuse is equals to the square of the remaining two